Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Centre, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident. Mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations, we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief. Experiments are performed, simulations studied, and exam questions are explored. not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner: learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment, and it's covered using fantastic Pasco software and hardware so that you can actually participate in the experiment. Also, lots of useful simulations, particularly from PHET, the photoelectric effect. You'll talk about projectile motion today, and also momentum. And then talk about applications like what would the International Space Station be without its solar panels to generate electricity. When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available, either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it'll show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014 because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck because that only helps with the multiple choice, but I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
Hello, Itumeleng. How are you?
I'm good, thanks.
Great. Thank you so much for joining us.
Yeah.
Why is the study of science so important?
Study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything. Just reading and doing, like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention and say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right. So I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I will speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now. PhD.
Now I'm doing PhD. Looking back, it's like, it never happened. So yeah, not giving up. Just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience, perseverance, it becomes very important.
Yeah.
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life, and eventually when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives. Just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
Yeah, it was the same for me. Like I said, somewhere, somehow I did get some zeros there.
Yeah.
But then through dedication and, you know, coming from where I come from, and you're at this side, you've made it to university, somewhere, somehow winning is the only option. You have to win, like it or not. You going back to where you come from, you're just going back to that life of drugs and whatnot. And that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot, I think you'll get there eventually.
You know what they say, if you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail grade 10 3 times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way. I'm a part-time lecturer at the physics department.
Listen to that. Listen to that. Thank you so much. Really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashele. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding, so always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry, so I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaha Madiga. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history, physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, and physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Physical science is very bad, then it means the whole science, engineering and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. If they're saying be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying you are all geniuses. You are all going to make it. What I want to tell you is believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult?
Yes, work energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here. Here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you are all right. Or, but Ara, which one? Oh, sorry. Who said that? You. Tell me, which Ara? The small Ara, yes.
You say rice, A plus B is C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T, and in the meantime, this is starting to increase. Hence, I have my plus T. And then at equilibrium, this is the end of your reaction. Nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. Right? Hey, I'm not going to complete this one. You can leave it there for now.
Sorry, Dr. Swela, you are muted. Can you unmute your mic?
Sorry about that. Good morning, learners. My name is Dr. Swela Kunwana. I am from the University of Johannesburg. Today, we are going to look into matric exam prep for paper 2. I am not alone. I'm with colleagues, Professor Mulawuzi and Nolwazi. They will be joining in as we are going through our discussion. Thank you. I am trying to share a screen. Bear with me, everyone. Okay. Today's topic, we will be talking about, just hold on. Apologies for the inconveniences. There's a hiccup on my side. Can everybody see my screen?
Yes, we can see your
Yes,
screen.
we can. You may just
Yes.
go to.
I want to do the slide, but I can't do it from my side.
No, go to slideshow.
I can't. So there's something blocking the thing here on top.
I can see your slideshow when I'm even here.
No, there's a black bar that was sitting on here.
Oh, there.
Yeah,
No.
there we are. Thank you very much.
Okay.
Apologies for the inconvenience. This is technology, my friends. It goes like this. Now, as we are preparing for the 2025 June exams, this is what we will be looking into. The rates of reactions, chemical equilibrium, organic chemistry, and acids and bases. Before we move on, your exam paper has got the first 10 questions that are on multiple choice. I know what we guys are doing. We always do the long questions, and then when that time comes, when they say to you 5 minutes left, then you start going to choose the alphabet randomly. If you're lucky enough, you'll get them right. If you're not lucky, you get nothing. But I want us to get into the habit of trying to solve the multiple choice questions. They're not difficult to solve, some of them, maybe out of 10, 2 will be difficult, but 8, it's doable. Like for instance, this one, it says the Maxwell-Boltzmann energy distribution curves below show the number of particles as a function of their kinetic energy for a reaction at 4 different temperatures. You are reading through. As you are reading, you are recapping and recalling everything that has to do with Maxwell. You know it has to do with energy and temperature and particles, obviously. And sometimes a catalyst might be brought in. So when it comes now to the part where you're going to read the question, first thing that comes to your mind is like, now I have all the information. Am I able to answer the questions? Let's see. You've studied the graph. There's A, B, C, and D, and that's the E, which represents the Boltzmann distribution energy. Now the question says, which of the following or the curves represent the reaction with the highest rate? A takes longer, obviously B will take longer, C will take longer, D, it was the quickest. You got your results faster than in A. Then you go to your possible answers to see which one will fall under D. And there you go. So it's just as simple as that. Let's learn to work our questions from the, from the multiple choice section so that we don't lose out on marks. 20 marks is a lot of marks, my dear learners. Now, moving on to the next slide. This is a paper extracted from Free State 2024 exam paper. It was a prelim. So you might get this or you might get something else that is different. Now, first thing we do when we see the question, we read. It says here, grade learners use a reaction of calcium carbonate with excess HCl to investigate the relationship between the concentration and the rate of reaction. Then you stop there. Then below they say the balance equation. Sometimes they might not even give you the balance equation. They will just give you an equation and they say unbalanced. Then you must expect to balance the equation. Or sometimes they will just give you this as calcium carbonate in words, or the hydrochloric acid. You are expected to write the formulas and then balance the equation, obviously. But this has not been assessed in a very long time. It might come back. Now you continue. They conduct the experiment twice, each with a different concentration of HCl. A decrease in the mass of flask and the content is represented below in the table. Now this type of a question, they used a table. You can either get a table or a graph. But what is nice about these types of questions, your answers are there. Once you see the graph or the table, you don't have to scratch your head to try and figure out where to source out information. It's right there before you. Now let's see if we are able to answer questions. It says they write down the name of the apparatus used in the mass. Write down the name of the limiting reagent. Define the term rate of reaction. These 2 marks, I demand every learner to give it to me so that it can pep you up. It's a definition, you must know it. For experiment 1, calculate the rate of reaction in moles per second in the first 30 seconds. Now, in which experiment did the learner use a higher concentration of HCl? Use the collision theory to explain the answer in 5.5. Now, before we answer these questions, you might be lucky enough that you were not asked the bulk mass, but it might appear somewhere in your multiple choice questions. And you can see this is 18 marks. Normally, these questions, they are worth 22, 18 marks or 17 marks. That 5 or 6 marks, it will be the bulk marks. So there's no escape, you need to learn it. And then another thing that can be assessed here, they can ask you to write down the investigative question, or you may be asked to identify the independent or the dependent variable or the control variable in these types of questions. Now, I'm just going to give you 2 seconds to try and answer these questions. I mean, this is 1, 2 marks. 5.4 we will leave out for now, and 5, and then 5.6 we will look into just now. I presume by now we know answers. If you know them, you can type them in the chat. We have someone monitoring the chat there to give us the answers. Or otherwise, you can just raise your hand to give us the answer. But for this part, let's not raise hands. Wait a minute, I'll let you know when to raise hands to answer the questions. This is what we're expecting you to give us for number 1. We want you to give us the answer as the mass meter. Number 2, what is the limiting reagent? The information is up there. HCl is in excess. Obviously, calcium carbonate should be your limiting reagent. That is the definition. In this definition, make sure that you have the change in the substance of whether the reactant or the product's per unit time. Your definition must include either one of these so that you can get your full 2 marks. Don't memorize it. Do it every day. It will register in your head eventually. Now, 5.4, like I promised, I'm going to skip for now, and then we will jump on to 5.5. The question was, which experiment did the learner use a higher concentration in HCl? We said it's experiment 1. Why would you say that? You need to explain that in the next coming question. Use the collision theory to explain the answer in 5.5. Okay, I promise to help you with 5.4. In 5.4, they said, calculate the rate of reaction in moles per second in the first 30 seconds. You've got 5 marks for that. When you see 5 marks, I don't expect you to crack or fret. It's easy. At the back of your question paper, you've got the formula, and number of moles is equal to the given mass over the molar mass of the substance that you want. You've got 1 mark for this. 1.6 and 44 is extracted from the table itself, and this will be the moles that you want. Now, the rate of the reaction, this comes directly from your definition. Remember, we said the rate of the reaction is a change in either number of moles, mass, volume, concentration, and so forth per unit time or per time taken. This is how you write down your formula. And the question asks, let me go back to the question. The question asks there, it says, report this in moles per seconds. Hence, your answer will be there in moles, and there are your seconds, and that's how you report your answer. So this is just as easy as you grabbing your 5 marks from the reaction itself. Now, the other question we asked, which one was faster? We said it was experiment 1. Why was it faster? Because there we had a higher concentration of results in moles per particles per unit. So it means here collisions were more efficient and they happen frequently and faster. That's why we had a higher rate of reaction. And hence we have the production of carbon dioxide faster than in the experiment 2. Moving on, the first part, it was still the rate of reactions, but we only had a table. This time around, it's the rate of reaction with the graph on it. And lately the graphs are all over. You go to paper 1, you see graphs. You come to paper 2, you see graphs. So again, I am emphasizing and repeating myself. Graphs have got all the answers that we need. When we see graphs, we are happy. Now, let us try to interpret what we see here on the graph. It says here learners are asked to investigate the rate at which 0.3 grams of impure calcium carbonate will react with the excess of 1 mole per decimeter cubic of hydrochloric acid at room temperature to produce carbon dioxide gas. First thing that I'm reading here, investigate. I know it's rate. I am expecting to be asked to write the investigative question. I'm expected to come up with the independent and the dependent variable. Again, I'm seeing impure calcium carbonate. Already, I am expecting to be asked to calculate the percentage yield, to be asked to calculate the pure substance that we want from the impure salt. Now we move on to the equation. Obviously, make sure that your equation is balanced. Now, beyond this, I'm looking at the graph. I'm studying the graph. I have nothing in the beginning. Then there's a slope or a steep, and then there's flat. I'm done with what I have exhausted from the graph so far, so good. Now, looking at my apparatus, I can see there's my calcium carbonate, there's gases coming out, there's a syringe. You might be asked, why is this syringe here? Let's see what happens. The graph below represents the volume gas of carbon dioxide produced at regular times. Ta-da! Write down an investigative question for this experiment, a control variable, and the independent variable for this experiment. Can we have answers from the learners? Just a quick 2 seconds before we move on to this. Learners? Okay, we seem to be having some technicalities with somebody. Professor Mulauzi?
I wanted them to be more interactive.
Yes.
And I was trying to check where the hand is. I can't see the hand on my laptop because the very first question that you discussed, we discussed the answer, but we didn't give them the basis of how we arrived at that answer. And by the time I wanted to try and come in, you were already too far. So I wanted us to do it that way, that exactly the way that you're doing it now. That there's a question and then we wait for them and maybe because you've already explained the experiment which was good, but maybe with 5.1.3 I think one other thing is we are assuming they know the difference between the dependent and independent. Maybe we should just give them a little bit background to refresh them.
Yes.
So
Please.
yes, but I'm
Yeah.
I'm following your lecture. It's very good. I also wanted to commend you on the quality of your notes. Excellent.
Yeah, but
Thank
the
you.
first part, remember I said I am going to give them answers and solutions, but coming forth, I will invite them to interact, which is what I'm doing right now. But before we allow learners to answer here, can you please just differentiate between independent and dependent variable and the control itself, because they are guessing this every time.
Okay, can I also suggest that learners can put their questions and answers in the chat line?
Yes.
So both those who are on YouTube and those on Zoom, you can type in the chat line. It's open.
Learners, please feel free. There's no stupid or very wrong answer. Remember, it's better to make mistakes now than in the exam. So hence, we want you to participate. Try. That's the whole purpose of today's workshop. We want you to be interactive and try. So please participate. We want you to be bold and participate. Dr. Brian, are they hearing us?
Yeah, if I can hear you, they can hear, unless if their devices are somehow impaired.
Yeah, because I can't even hear a single rustle of any sound, and they are so quiet. I see we've got 21 participants. It's including us probably, but I'm just worried. We too quiet, us as learners. Please, learners, we're inviting you. Dr. Suwela has sacrificed a Saturday to help you. Please help us by participating. We know you know the answers. We just want to polish your answers.
Okay, Prof, I think we need to proceed from now on. Maybe they will catch on as we're moving along.
All right.
Yeah. So now, learners, when it comes...
Good morning, ma'am. Good morning, sir. Can you hear us?
Yes, we can.
Okay, we have an answer for 5.1.1, but we're not quite sure if it's the right answer. But what we wrote down is, what is the rate at which 3 grams of impure calcium carbonate will act with excess HCl at room temperature? And then for 5.1.2, we have temperature.
And then point 3?
The rate of the reaction.
Perfect. Let us see. Let's check your answers and see. First and foremost, 5.1.1. There is no specific words to use. Like, you know, when you use the formula, N is equals to concentration times the volume. Here you can use any word, your own words, as long as in your words you've got the keywords that are needed to answer this question. And that will award you your 2 marks that you need. You see, you said...
What are the keywords that we're supposed to use? What are the keywords we're supposed to use?
Between the concentration and the rate of the reaction. You've used that, you got it correct. But be careful not to include too much information in that answer, because it's only 2 marks and you will run out of time while trying to answer other questions.
Okay, ma'am.
Okay, so you got the solution there in front of you, right? And thank you for your participation. I'm looking forward to hearing from you again.
Okay, ma'am. Thank you.
The second one, we said it's temperature. There you go. Hey, Wena, you are my guy. I'm telling you. And lastly, the independent variable, you said the rate of reaction, which is what we're looking for.
Yes, ma'am.
Perfect. Next. Okay, I'm going to move
Thank
on
you,
to
ma'am.
okay, thank you. I'm moving on to the next part. The next question now, it says, with reference to the graph, how will the rate of reaction between time of 0 to 20 seconds compare with the rate of reaction between the 20 and the 30? Let's see. Where's my graph? I'm moving back. Sorry again. Here's my graph. They said between 0 and 20, and then again between 40 and 50 seconds. Can you see that on the graph? I've got this part, and then I have the other part. Now they want to know the rate, the differences between here and there. What differences are we seeing there, Learners? Anybody? Okay, guys, without any waste of time, because I can see the responses are taking longer to come, I don't want to be giving out solutions because you're not learning anything from me giving you the solutions, but preferably get the tips that will come out as we are giving out solutions. We're saying here at 20 and 0 and 20, the rate will be faster there because it's the start of the reaction. And then later on, it will be slower. And eventually your reaction will stop. Now it says here, what conclusion can be drawn from the graph between the 60 and the 70? Nothing is happening there. You have collected all your carbon dioxide, your reaction is stopped. And you can see, let me see if the next part has got, yes. As you can see here, this is between 60 and 70, it's flat, nothing is happening. But then between 40 and 60, you can see the graph is starting to become flatter as compared to between 0 and 10. There, the graph is steeper. So that's how you are able to get your answer. Remember, I said, when you see the graph, you must be happy because your answers are sitting there on the graph. Now, this is the part that I said is coming. Use the graph to calculate the mass of calcium carbonate that reacted. The molar mass, it's this at the room temperature. This will be given to you. If it's not, we can grab it from the back of your question paper under the information sheet. But otherwise, you can use the one that is given to you.
Oh, sorry, ma'am. Can ma'am yours?
Yes.
We have a question. For the rate of the reaction, is it correct if we assume that the faster the steeper the slope, the faster the reaction?
Yes, that's what it says.
Okay.
Yeah. Remember
Okay,
here
thank
you
you, ma'am.
started off with nothing. To get to this volume, it was faster. It went like shh. And then here it's flat, nothing is happening. You're not producing anything beyond here. Can you continue with 5.4? The tip here is to know your formula, which is at the back of your information sheet. 0,025 is extracted from the table. And the 24 is the one that is given to you. Like I said, this is something that you grab from the graph itself. The most important thing here is to remember the stoichiometry to get the mole ratio between the carbon dioxide and the calcium carbonate. The question said calculate the mass of calcium carbonate. But on the graph, the information that you see here is of the carbon dioxide, not the calcium carbonate. So bear that in mind. It's just that here you got lucky that the mole ratios are 1:1. Sometimes the mole ratio can be 1:2. So you can't use this number of moles directly to get the number of moles of the other unknown. And then from here, this is how we grab our 5 marks. 1 mark for the formula, 1 mark for the substitution, obviously that we got from the graph itself, and then we continue with the calculations. Now the 5.5, remember I said when you start reading the question, it said impure calcium carbonate. And when you see that, you must expect to be asked to calculate the percentage purity. There it is. It's sitting here. This formula is not given to you in the back of your answer sheet. You must know that this will be the mass that you have calculated, the theoretical mass, and underneath there it will be the given mass on the statement itself. Now, should you happen to do this calculation and you get your percentage to be above 100, then you know that you have mixed your masses. Whatever pure substance that you need, it is within the impure. It's like you making a coffee. You add sugar, coffee, and milk and water. So that coffee is not pure anymore. Now, if you want the purity of your coffee, it will be that portion within the big hole. Now, within that portion, you're expecting to get your percentage to be less than 100. If it's more, then you know that you need to swap this around, irrespective of whatever answer you got up there. Now, before we continue, do we have anything that we need to ask? Okay, just before we move on to the chemical equilibrium, rate of reaction, it covers your definition. You need to understand your investigative questions. You also need to differentiate between the independent, dependent, and the control variable. And again, the Boltzmann, in the Maxwell-Boltzmann's distribution curve. And again, they might ask you about the endothermic and the exothermic graphs that we have learned in grade 11 already. They might pop in here and there. So that is just a general sum up of what we need to bring when we try to solve any problems that has to do with the rate of reactions. And now, colleagues, I'm going to move on to the chemical equilibrium. Okay, before we move on, let us continue again with this rates of reactions. I'm sorry about that. Now it says here the learners repeated their investigation by using the 0.3 gram of the mass. But then they increased the concentration of the hydrochloric acid. Instead of using 1 molar, they've used 2 molars. Obviously, the question before we move on. If I change the concentration to 2 molar, will my reaction be faster or slower, the rate? Can we get an answer to that? Okay, before we answer, we have learned from grade 11 already, when we did chemical change, we said the higher the concentration, the faster the rate. The higher the temperature, the faster the rate. And then you say when you add the catalyst, your reaction will move faster. And the higher the surface area, the faster the rate, or the larger the surface area. We have increased the concentration here. Obviously, the rate will be faster here. So that means our gradient will be steeper. So we are looking at somewhere between the 0 and the 20, the steep. Obviously, this one, it will be even higher up here instead of it going flatter. Now again, it says use the collision theory to explain how an increase in concentration affects the rate of reaction. Before we come here, remember in that paper from the Free State, this question was asked. It's coming back again. Only this time we are focusing on the concentration. Before we even show you the solution, remember with the concentration, we say if you have a container And in your container, you've got particles that are dense, like packed. These particles, they have an opportunity to collide with each other faster because they are closer to one another. And remember, once they collide, they gain kinetic energy and they will move faster. And once they move faster, they'll be able to collide or bond with other particles so that they can form new products. That's how your rate of reaction is sped up. Now, let us see what we should have given out for number 5.6.1. We did say it will be steeper because we said the higher the concentration, the faster the rate. Again, this is what is expected of you. We need to see that you have increased the number of particles, obviously. There will be more collisions and the rate will be faster. I'm moving on to the next phase if there's no questions under the rate of reactions. Now, this is the chemical equilibrium. Before we hop on or jump over, there's something that needs to be addressed here. You need to define again. Remember, definitions are all over. Here we've got two types. You can either define the chemical equilibrium or you can define Le Chatelier's principle. These 4 months I demand of you from this section before we can do anything else. And then we can recall there's an endothermic and exothermic, there's a Kc, there's temperature involved. And once you see Le Chatelier's principle, you know that you are looking at those factors that will affect or change or disturb Le Chatelier's. That will be the temperature, concentration, catalyst, and the pressure. So all of these things we keep in line so that we know that when we want to answer questions, we are impaired. Now, it says here potassium dichromate is formed when nitric acid is slowly added to potassium chromate solution, which is what we have here. The chromate ion in the solution reached equilibrium with the dichromate ion according to the Pauling balance equation. Before we had the products forming, the solution was yellow. And once the reaction was complete, we saw orange. This is now at equilibrium. Again, define the term chemical equilibrium. You know what is nice about me? I don't like giving out definitions to learners. You need to fish them out yourself so that you know them. Now, 6.2, it says a concentrated nitric acid solution is now added to the reaction mixture. What will be expected of me? I'm expecting to see either orangey or yellow. Remember, I just disturbed the equilibrium by adding the concentration. The question asked here is that what color will be observed in the mixture? Will it be yellow or orange? And lastly, explain your answer in 6.1 in terms of Le Chatelier's principle. Now, before I move on to above here, I'm just going to explain what is happening here, because I can see you are not well prepared to give us answers, but let me just give you the background. So when you're sitting at home trying to answer these questions, you will know what to do. I have here H+. First and foremost, these are my salts. That is the water that doesn't play any part in this. This is the H+. Whenever I see A+, I relate this to an acid, from acid and bases. When I see OH-, it relates to the base. Now, they say a concentrated nitric acid is added here. It means I am increasing the concentration of H+ by implementing the common ion effect. What does that mean? It means by adding the nitric acid, I am increasing the concentration of H+. Now, once I increase the concentration of H+, where do I expect my shift to go? Will it go to the left or to the right? Remember, we said when you increase the concentration, you are disturbing the equilibrium. So I've got more of the H+ on this side. The system can't keep up. So it will shift in such a way that it reduces the H+ and it will move to the other side and it will favor the forward reaction. Hence, your solution here will come out orange. Now, my learners, you see this question here. This was supposed to be up there and this one was supposed to come suit. But they put it this way so that they try to confuse you. But you know your stories, you know you can do this. You know you are able to answer and say, I'm starting with 6.2. I want to understand what is happening here. You can't just guess yellow and orange and then come and justify your yellow and orange. You need to work it out. Now, we've answered your 6.2. We are implementing the common ion effect. We've increased the concentration of H+. This sets the equilibrium. It causes the equilibrium to shift to the right or it favors the forward reaction. Hence,
hello, ma'am.
Just hold on. I'll give you the platform now. Hence, your equilibrium will shift to the right. And now you can go back and answer number 1. Your answer will be orange. Now, can you hear from you?
Can you please repeat 6.2.2?
2.2, this is the common ion effect. I am increasing the concentration of the H plus by 18 the nitric acid. Remember, H plus and nitric acid are both acids.
Yes.
Are we fine with that one?
Yes, I'm fine.
So once you increase this concentration, you are disturbing this equilibrium. The system will want to shift to the opposite direction. Hence, it will favor the forward reaction.
Okay.
Now you can go back and answer 6.2.1. Your answer is orange. You see, you didn't even guess it. You worked it out.
Okay, thank you so much.
All right. Thank you for your participation. Now, when the temperature of the system of the mixture is now increased, it is observed that the color changed to yellow. Now, this is the third equilibrium. Are we clear?
Yes, ma'am.
This was the first equilibrium. We added the acid, we disturbed the first equilibrium, we got the second equilibrium, which is now the orange. Now to this orange, we increase the temperature. What happens when you increase the temperature? You are disturbing the system. Now the third equilibrium is obtained. The mixture is now yellow. Ne? The
Yes,
question
ma'am.
now asks is the forward reaction endothermic or exothermic? I'm not able to answer this one myself. I jump off to the next question. Explain your answer in 2.2.1 by using Le Chatelier's principle. The first thing that I do, I am bringing my endothermic and exothermic reactions. They are talking about the temperature here. Now, I'm bringing the equation from the previous so that I see what is happening here. They've increased the temperature. The color observed was yellow. Now, normally, this would be your reactant and your product, P plus heat. This will give us the exothermic reaction. True or false? And then again, in my reactant, if I happen to add the heat on this side and get my product, this will give me my endo, meaning I require heat for this reaction to happen. And here, heat was given off at the end of the reaction. Now, going back to what is happening here, when we increase the temperature, if I increase the temperature here in this scenario, what will I get? Will I have R or P? Remember, for the reverse reaction to be favored, this reaction requires me to heat up the system. So if I increase the temperature here, it means I'll have more of R. And if I decrease the temperature, I'll have more of the product. So according to this, if the temperature is increased, I will have more of the yellow and less of the orange. And if the temperature is decreased, according to the first setup, according to this one here, If the temperature is decreased, I'll have more of the orange than the yellow. Now, this is in the case of the exothermic reaction. In the case of endothermic reaction, if I increase the temperature here, I'll have more of the product of the orange. And if I decrease the temperature, I'll have the more of the yellow. But the statement said,
Hello, ma'am.
Hello.
Can I try answering?
Yes.
According to the Lee-Shatley, an increase in the temperature will favor the endothermic reaction. In this case, the endothermic reaction is the reverse reaction. Then the reverse reaction will be favored.
The reverse reaction will be favored, but remember the statement said here, the temperature was increased. You see that?
Yes.
So for the endothermic reaction, which is here on this arrow, if I increase the temperature here, I get more of the product, which is the more of the orange. So this eliminates this part, meaning I must only focus on this one here.
Yes.
So if I increase the heat here, I will have more of the R, which is the yellow. So now you can come and say the reverse reaction is favored.
Yes,
Yeah,
ma'am.
I think when you only slip up with the endothermic part, but your explanation and your answer was correct, except for you said endothermic instead of exo.
Yes, ma'am.
Yeah, are you getting it now?
Yes, I am.
Okay, thank you very much. Anybody else before we move on? Okay. This one is something else. This is the rice. The rice is the Kc calculation. First things that you need to recap here. Kc is related to the temperature. When you are dealing with an endothermic reaction, you say when you increase the temperature, the Kc increases. When you decrease the temperature, the Kc decreases. In the case of exothermic reaction, when Kc goes up, the temperature goes down. And likewise. Now, if you want to write the relationship between the two, you say in endothermic reaction, Kc is directly proportional to the temperature. And in case of the exothermic reaction, Kc will be inversely proportional to the temperature. This question might not be asked here, but in other questions, it might pop up. I see there's an 8 marks here, and I don't expect people to pin over this. Okay, now it says here 11 moles of chromate ion and H plus are initially added to make a volume of 0.5 liters. When the reaction reaches equilibrium, the solution contains 9 moles of dichromate ion. Now calculate the initial mole of H plus. This 8 marks. We start off by building the table. This is the rice. We know we need initially the reaction, the change, and the equilibrium. Your rice will look something like this. This is your equation, balanced as it is. Initially, you have something of here and there and nothing there. As the reaction progresses, the change comes about. This starts to decrease, and that starts to decrease, and that starts to show or form or increase. And at equilibrium, we have the remains of what was in the reaction itself. I put the Y and the T here as the dummy values so that we understand how to build a table and insert correct variables on the table itself. Further on, we were given that 11 moles of dichromate were there, and there they gave us X, and that's 0. So all this information comes directly from there. In the T, I put my X. In the Y, I put my 11 moles. I put the moles there because they gave me moles up there. This is the change, and that will be the change and so forth. I chose to place the X with the A's because there's an X there that will confuse us. And at equilibrium, we have this minus that and so forth, but this is in moles, except for this one here. Now,
Ma'am,
yes,
ma'am,
yes.
I don't understand. Pardon me. Why at C do we have minus 2x, and for the product we have plus x?
Aha. Because of the reaction. The reaction, there's 2 moles of chromate ions reacted with 2 moles of HRs to give us 1 mole of dichromate ion. Hence, during the
Oh,
change.
thank you. Yes, thank you. I now understand. I didn't understand. I just saw you write minus 2x. So I was wondering where they are from. Thank you. Now I understand.
Thank you very much for understanding. Let me emphasize more. If I had a 3-day, I would have added a 3-day. If I had a 4-year, I would have added a plus 4-day. This is just the stoichiometry to balance our equation. Okay. So now in this table, I've got moles there. There I've got moles per decimeter cube. There's the mole and that's the concentration. So I chose to work with one set of units. I converted the moles into the concentration by dividing this by the 0.5 volume up there, and again the X by the 0.5 so that I can get all the moles together. So where I have my A's, I'm going to explain where the 9 is coming from. Here, the X, yeah, let me move from here. The X is just 0 plus X will give you the X, which is what is happening here. The 0 is that one there, the plus X is the formation, and at equilibrium, I was left with a 9, which was given to me in the question up there. So now this is my start to balance my stoichiometry. I got 9 moles during the change. 1 mole of dichromate was produced from the 2 moles of H+. Hence, I'm going to double the concentration of the dichromate by 2. And again, I will do the same for the chromate ion. So the 22 is 11 divided by 0.5, and the 18 is from the 2 times the 9 plus the mole ratio. Can I move on? Now that at equilibrium, we've got the concentration of the chromate ion to be 4, H plus 2x minus 18, and that of dichromate ion is 9. I am able to execute my Kc expression. Remember, we said Kc is the concentration of the product over that of the reactant. Water concentration is 1, hence it does not appear here. Remember, anything multiplied by 1, it will be anything. A times 1 is A. 1 times 1 is 1. 2 times 1 is 2. So we have, from the table itself, we have the concentration of the dichromate to be 9. That of the chromate ion, it's 4. And of the H plus ion, it's 2x minus 18. Remember the coefficients that we have there. We must not forget them here and there. There we can solve for our x and get the initial moles of the H plus ion in our solution. The most important thing here is to know what information to put in the table. And the catch, when the reaction reaches, you see there they said reaches equilibrium, the solution contained 9 moles of. Sometimes they will say the change was what, or something of that sort. The change that they talk about is what we add or include in this change here. Once you get this, you sort it. Sometimes they will give you the initial and the equilibrium. For you to find the 2, You just subtract or add so that you can get this one here. Same applies. So here they give us the initial and the equilibrium. We worked it out so that we can get the change, and then we can work throughout or backwards to get the answers that we're looking for. This is the case of the KC, and I am sure most of us can really build the KC table and do the calculations better than I can. But before we move on to the graphs that falls under here, can I move on? Okay. This is still the chemical equilibrium. I'm not going to attempt to answer all of this at once. I just want us to understand what is it that we are looking at here. First and foremost, we've got nitrogen gas and hydrogen gas with ammonia. These are my reactants, and that will be my products. At this stage, I don't know whether this is endothermic or exothermic. We will determine this by reading through the questions. Initially, I have nothing here, and I have something there. So this tells me that already this is my ammonia, the solid line. And the dotted line will be my nitrogen and hydrogen because I have something there. And during the change, as the reaction progresses, the nitrogen and the hydrogen start to decrease slowly. This is the minus X. And now here, the ammonia starts to form. This is where the plus X comes in. This will go on up until you reach this part where we have our first equilibrium. Now at B, this equilibrium was disturbed. Something was changed here. It was added. The system was disturbed, and then it obtained a new equilibrium. This Sharp's principle applies here. After this new equilibrium, something else again happened. The system was disturbed yet again. After disturbing this, a new equilibrium was obtained. So we've got 1, 2, 3 equilibriums and 1, 2 disturbances that took place here. Now, the thing that we need to understand when looking at the graph directly, when you are asked what was disturbed here, what is it that was added to the system to change the piece? 4 factors, remember: catalyst, pressure, temperature, and the concentration. When you see a nice pattern that repeats itself like this, expect a catalyst to have taken an effect in this whole disturbance. Now, when it comes to pressure, I'm looking here at my reaction. I've got 1 mole there, 3 moles. On my left-hand side, I've got 4 moles. On my right-hand side, I've got 2 moles. So the moles are not the same. But if I had 4 moles on this side and 4 moles on the other side, it means the pressure will not have any effect whatsoever in the equilibrium. So in that case, when I have both sides of the moles equaling each other, the curve will look like this again. So therefore, on this one here, I have only one possible disturbance that could disturb this curve, which will be the catalyst. Now, when it comes to such on this side, there by C, I am expecting to get 2 possibilities here, the concentration or the temperature. By looking at this on its own like this, it's not easy to tell whether it's the temperature or the pressure. You do get those graphs when you have 2 of them. You will see the sharpness. This line will just go down there and then it goes out like this. Then you know that the temperature has been the affecting factor. But sometimes when you come across a smooth curve like that, you know that the concentration has disturbed the system. But here, because we don't have any more of a comparison, they will tell us what disturbance took place here. Now, once we have digested all of this, we know how to answer our questions. I am not going to define this. Again, I told you, you must give me this answer for 6.1.1. 6.1.2 says, identify the change made at B. I just told you, what changed at B? The catalyst changed. Now, there is a temperature change at C. Again, like I said, if it is not told what changed? You will be able to tell because then you will have two differences from the same graph. You will be able to tell whether this is the temperature or the concentration. But in this case, we are lucky enough, they told us that the temperature has changed. Now, there was a change in temperature at sea while the pressure was kept constant. How did the temperature change? Was it increased or decreased? Write only the answer. How do we know that? We check. You see what happened here? The reactant decreased and we had more of the nitrogen, of the ammonia gas. Now, before we can even bother to answer this, and then they come back and ask us, was this an endothermic or the exothermic reaction, the forward reaction? Then use Le Chatelier's principle to answer the same question. These questions are similar and they are the same with the same one that we saw in the previous paper. Remember, that one originated from just a random question without a table or a graph. This one came from the graph itself, but the concept is the same. I said the temperature decreased here. I'll tell you why it did. We said this is an exothermic reaction, and then we applied the Le Chatelier's principle. Now, let us see how we came to those answers. Same old. Reactant, this is an exothermic reaction because heat is given off. But here, this went down and this was increased. So I have more of this and less of that. So if I increase the temperature here, it means I'll have more of R. And if I decrease the temperature, I'll have more of the product. And the statement up there said, we opted to say the reaction is exothermic. Now, let's look at the second scenario. This is the endothermic case. What happens when I increase the temperature here? I'll have more of the P and less of the R. This definitely, my friends. Okay, if I decrease the temperature, I'll have more of the R and less of the P. Now, between the two scenarios, which one is applicable to this for the forward reaction? Can I have solutions?
Ma'am, can I try?
Yes, please.
So according to the Chatelier, an increase in the temperatures favors the endothermic reaction. In this case, the forward reaction is an exothermic, meaning that wait. Okay, yeah. Meaning that the reverse reaction will be more favored because there was an increase in the temperature.
Exactly, perfectly so. But remember, this will be the key. These formulas here, you need to write this down and manipulate and see if this happens, what do I have? If that happens, then you're able to conclude your answers based on these basic solutions that you have there. No,
yes, ma'am.
We're not guessing here, we work it out.
Yes, ma'am.
Okay. Thank you very much. I think we are ready now to move on to the next section. But before we do so, yes?
Yeah, I wanted you to put that one. I want the learners to really look at what you did there. That with this one, I'm not sure if you can see, you won't be able to see my arrow because I'm not sharing. But the left-hand side one, where
This
you've
one
got
here.
the reactant and you've got the P plus the heat.
Yeah. Which one? Or
Yes.
this one here?
Yes. Yeah. You've done it very well. All they have to do to remember is that if the heat is on the right-hand side of the equilibrium, then it is your product. If it's on the left-hand side, it's a reactant. Then that will help the young girl who was explaining to explain it much better. Because here you've done it for them very nicely. They can see that the heat is the product. It's exothermic, and the heat on the right-hand side, it's your endothermic because it's on the left-hand side. So I wanted them to note that because you've done it already for them up there, because these explanations that you've given them would give them a hint. And this is the best way they can remember it. Thank you very much for that.
Thank you, Prof. And thank you for the participants. Now, this will be the organic chemistry. I'm just going to put up the whole slide so that you see what is it that you need to know. We've got reactants and reagents. These reagents are the ones that sit over the arrow, like here. And again, you need to understand that there's elimination and substitution reactions. And what goes under what is eliminated and what is substituted and what is also added within organic reactions. Without any delays and waste of time, I know that we did not allow enough time for the organic chemistry to be slotted in, but it is going to be written in these prelims. So it's just the heads up and the reminders that this is what we expect of the learners to know. I know that you know what is elimination, substitution, and addition, but over the arrow here, this is what troubles me the most with your learners. You remember the OH, the H+, the solvents, the catalyst, and so forth. You see here, if you have your phones now, you can snap this. This usually go over the arrow. In case you get stuck somewhere, you don't know what. I've got the OH here. What must I put there? The OH and the H are together, husband and wife. Always. When you see H+ there, you will have an OH there. And vice versa. In the solvents, it can be the catalyst. You can use the hydrogen gas, the platinum, the palladium, or the heat. Hold in any of this, you will never go wrong. The only part where you will go wrong is the OH and the H+ that you need to know here. This is an alcohol, it's got an OH. Recall acid and base, they are together. So once you see a base, you need an acid. Now, in the case of an acid, that will be the HBr, the HCl, the HI. Once you see an I here, you know that you're dealing with an acid. There on top, there you will have an OH. That's just the bottom line and simple and straight to the point. Only this will be required for you to add. Can I move on to the next slide? Before we can have questions. These are the conditions that I was talking about here. Well, this one is addition. I'm just going to add something on here. And I'll have my acid added on. There's the catalyst or the heat. Here, I've got this and I have that. You see, I've got an OH there. What must I put in there? I'm going to put an acid. Or I'm going to put water. So that, remember, water can act as a base and an acid. So that I can have this added onto this reaction. Now, the next bit, there is Markovnikov rule and Zaitsev rule. This, they talk of the major and the minor products. I think I will spend 2 minutes or so to talk about this, and then we will close the organic chemistry, and then I will show you the acid and bases, because that one is even more pressing than organic chemistry, just so unfortunately. Now, I have my initial reactant here with my double bond. This carbon has got 2 hydrogens, and that one has got 1 hydrogen. If I'm adding water to this, I am expecting the O and the OH to sit on either one of the carbons. So I've got 2 cases here. In case number 1, I have my H sitting on this first carbon and the OH sitting on the second carbon. And in the next product, I've got the OH sitting on this first carbon and the H sitting on the second carbon. Now, I've got the two scenarios here. This is where now we apply Markovnikov. We say your H must sit, the OH, I'm sorry, it must sit on the carbon that has got fewer hydrogens. This carbon has got one hydrogen, that one has got two hydrogens. So my OH, I expect it to sit on here and the H to sit there in this case. Hence, this will become my major product. It is a major product because this is a stable compound. It's not easy to remove the OH because you see it's guarded by two other H's on either side. Whereas in this case, my OH is sitting near the edge. It's vulnerable. It's easy for me to add an acid and remove this OH, unlike when it is sitting here. When I add an acid here, I must start with this H and then come here. So that makes this one an unstable product. And this will only be 1%. And this will be 99% of your products. So remember that your OH or your Cl or your bromine or your iodine will sit on the carbon that has got fewer hydrogens. Now, when it comes to DITAF, this is addition reaction. This applies to elimination. I am trying to remove the HBr. Here I am adding, here I am removing. I can also remove I'm sorry about it, I can also remove the H and the OH, which will be the water. Now, remember what I said to you, HBr is an acid. Once you have an acid over the arrow, you will add a OH minus. It's not something that you can just memorize or anything else. Just keep tabs, like what goes with you. It's a matching pair in a sense. You can just write solvent here. The solvent can be an organic solvent, or you can just say a catalyst or the heat here so that this reaction can progress faster. Now, I've got this carbon that is sitting in the middle of the two carbons here. I have the chance or the option of having a double bond here or the double bond there. Again, with the case of Markovnikov, we said the OH will sit on the carbon with lesser hydrogens. I am expecting my double bond here to sit on the carbon that has got less hydrogens. This carbon has got 2 hydrogens. This one has got 3 hydrogens. So my double bond must sit on this. That will give us the major product, like in this case. If my double bond is sitting on this carbon, it means I'll have my minor product. I saw Zandi try to say something here on the screen. Let us give you a chance to communicate with us, Zandi. Zandi?
I did by mistake, ma'am.
Oh, okay, right. Remember the experiment? Some of you in your schools, you did this, you watched the video, some of you did this practical. You start with your alcohol, your carboxylic acid, you need an acid, and plus heat, so that you can form your ester. And your product formed will be water. And that will be it. I'm sure this one was thoroughly explained to you in your practicals or exposés. But bear in mind, it will come in your test or exam. Lastly, this is the part, this is question 1, 2, the 4th question in your paper. This is something that I need you guys to go and sit and work on thoroughly. It's catching and pressing and dangerous, but the tips that I gave you in the previous questions, you need to go and apply them here. I've got A, B, C, D, and E. First thing I do here, I look into this chart or the scheme. What happened here? I see there's a double bond. From here to there, I added HBr. This is addition reaction. From here to there, there's an X or Br, and here there's an alcohol. There's a substitution. From here to there, or something happened here. From this Y to there, or there's a major and a minor product. From this one to there, I am seeing something like I had an alcohol with one OH, now I'm seeing another. So it means an esterification took place here from the look of things. And then from here to there, I see there's a double bond, and then I see now single bonds. So it means I have added something. This is addition. So I just went through to see what type of reactions took place here before even starting to attempt to put the reagents in between the arrows. There they give us HBr. From here to there, I am removing the HBr. So it means here I'm going to add the OH minus to remove the HBr. Here, I've got the HBr, which is the acid. I'm going to have a strong base here so that I can substitute the X and the Y. And then from here, I have an alcohol. I need the carboxylic acid, the acidity, and the heat. So I'm going to write carboxylic acid on top. Underneath, I'm going to put the triangle and the catalyst, which is the acid, the sulfuric acid. And when it comes to acids, and they want you to write the acid, most of the acids that you will write is phosphoric acid as a catalyst and sulfuric acid. HCl, most of the time, they participate in the reaction themselves. They form products. Okay, remember on top of the arrow, you have the HBr. Underneath there, you'll have the heat, the catalyst, platinum, hydrogen, or the acid. Those are the ones that will come underneath here. That acid will be sulfuric acid or phosphoric acid. Don't go beyond your scope. Stick to that. You'll never go wrong with that. Now, once you have done all of these things, you wrote them down on your question paper. By the time you come here, write down the type of reaction occurring at A. You know it's addition. Or you can say hydrocombination because you already wrote your answers here on top. Before I move on to looking at acids and bases, we have limited time left. Can I ask if you have any questions? Then we can move on to the next part. Okay. Acids and bases. This part is one part that I'm confident with. I know that our learners, they excel at this. They do. I mean, these are definitions. The only catch here is for us to recall and read our questions thoroughly. This is Laurie Brownstedt, and we've got Arenas. Laurie says acid donates a proton. Arena says acid produces H plus in solution, and likewise the bases. We've got a diprotic, monoprotic, and triprotic acids. It is very important for us to know the differences between them. Yesterday, I was asked what is a diprotic. One of the learners said, "Hi, Wena, we know it's an acid that can donate 2 protons." I'm like, wow. So you do get every now and then that particular person who missed out on energy. It's not like he did not understand that a sulfuric acid can donate 2 protons. It was just the term that came to his mind at that particular moment. So I'm urging us learners to go and recap and familiarize ourselves with the terms so that when we come across such things, we don't get shocked with what we see in here. Now, we're going to attempt to answer all of these questions and then we move on to that catching. Write down the analysis of reaction. Write down the formula of that base. Remember, I said here, read. Don't just go ahead and answer. Next part, there's our diprotic acid, donating 2 protons. There is our triprotic. This is the one that caught that student yesterday. He said, "What is tri now?" I said, tri, it means 3. It's mono, di, and bi, and tri, and tetra. And then they went on and completed the series for me. And I said to them, this acid can donate 3 protons. That's when he caught on. They're like, oh, now I remember. So, yes. Now, this one, it can either be an ampholyte or the other. The other one I chose not to use because my tongue does not know how to pronounce it. But I'm expecting learners to know. Either you can say an ampholyte or the other one. Can somebody just type it for us in the chat room so that we know what is the other word that you can use for the underlined phase there? Conjugate acid-base pairs. This is something that you don't just, it's easy. Just pair the husband and the wife. Then you know from there. I normally start with this one here because it's an OH. We know it's a base. If this is a base, that one automatically becomes an acid. And if this is the base, this one is an acid. So therefore, the other one will be the base. Once you have labeled all of this, then you will know what sort of answers you're going to put there. Before we move on, any questions, opinions, suggestions, input, contributions? This is the question that I was referring to. This question and the next one that comes, I am going to send you a separate information on these types of questions. Okay, let me start off by saying this. Let me read this one through to you, and then I will explain what is the plan here. The plan here says a chemist calls sulfuric acid in a lab bench. To neutralize this, they added sodium hydrogen carbonate according to the following reaction that took place there. I have the concentration and the mass sulfuric acid and the sodium hydrogen carbonate. That's all I have. So for me to answer anything that I need to know from this problem, I'm going to need known and the given information. The start of this one is only the concentration. I can't do anything beyond that. But this one is the mass. It will give you the number of moles for that. That will give you the number of moles for that. And then from there, I can solve anything that I want in this problem. So this one, it was not a pressing matter. 1 mark for the formula. Then you substitute into the formula to get that. This is the sodium hydrogen carbonate. And then we apply the stoichiometry to solve anything that we want. So we don't expect any funny things with this one. The 6 marks will come. And remember, use your periodic table constantly to answer your questions. Now, this is the one that I want us to look into. This is the carry on to the previous question that was used. Yeah, they say the chemists now dilute some of this sulfuric acid to this. This is a dilution factor. Now, in this dilution, we have flask 1 and flask 2. Just like when you make oros, drink at home, you take some from the syrup into your glass and then you add water. Obviously, the one in your glass, it will be less diluted than the one from the original scoop. In this case, the original scoop is this one here, the 6 molar. In your glass is the 1 molar that you made. This is strictly and straightforward dilution. Now, this is given at the back of the formula sheet. Originally diluted, concentrated, diluted. The concentration here is 6 molar, I'm sorry. The volume, calculate the volume of the 6, it's unknown to you. The concentration is the 1 molar. What was made of this volume? It was, I saw it somewhere, 1 liter. Okay, so once you substitute into this, your answer should be 16.67. I'm sure learners are able to get that answer. I deliberately not solve this. I only gave you the answer so that you can solve this on your own. Now, during the titration, this volume of the new diluted solution. It was titrated with sodium hydroxide, I'm sorry. They used the bromothiamol blue as an indicator. Yeah, something that we also almost forgot here. The indicators. There's a table on indicators. The indicators, the titration, and the tables. I am going to send you a special video to solve this particular question, the 7.3.4. It's a long, complicated question. It's going to take us an hour or so to solve. So by Friday, not Friday, on Friday, the 30th of May, we will go to YouTube. You will find the solution to this one here. There will be a link that will be published to everybody so that we can understand how to get the 8 marks. It's easy. The 8 marks is sitting there, but we must break it down in bits and pieces so that we know what we want. And now, ladies and gentlemen, from my side, I'm going to pause and allow my colleagues to add on something, and then learners can also come in and ask questions or add on what they have learned and share with the rest of the world. Professor, over to you.
Thank you, Doc. That was splendid, excellent. That was Woolworths quality. May we kindly go to the very first one which you did, the one that I was referring to, because I want them to try and grasp. The very first one, the very first slide we started with. Sorry to take you that back far, because I think my students have the same problem. Very first one.
Yeah, we went far, man. Yes, like.
Yeah, that's why I had to say sorry. sorry.
This is the first one.
Yeah, this one. Okay, no, they go a little bit up. I think it's the very first slide.
Yeah, Boltzmann.
Yes, good. This one.
This one. Okay.
Yes. I want the learners to look at the number of particles on the left-hand side. Okay? On the y-axis. And the distance between where they've set kinetic energy. Yes, good. I want them to try and compare A and D and understand which curve represent the reaction with the highest rate. That's all, because it also gives my students a little bit of trouble. So I thought maybe if they can just look at the diagram and try to say, why are they saying it's D, C, B, or A? Because if they do that, then I'll be happy. We can help them, but I'll be happy if they can try. Because I want them to look at the broader base and why they can now relate it to, and there's return kinetic energy. Learners, I want you to help me there. I want you to help me there. Which one did we choose there and why? Dr. Suwele has been very generous. She's been giving you hints. So I don't want you just to memorize that one. And I don't want this question to eat away the time you could have for other questions. But I felt it's very important that you do not memorize there. Zoli, so I want you to try. Zoli, so I want you to try. Do you remember what ma'am said, which one you should choose? Any among the learners, do you remember which one she said you should choose?
May I try, sir?
Thank you. Please try.
The number of particles in graph A is higher than the number of particles in graph D, and the kinetic energy between graph A and D. The kinetic energy in graph A is smaller than the kinetic energy in graph D, which is why I chose curve D as the reaction that has the highest rate, sir.
Okay, thank you. Now I want you to remember this. From where the two lines meet, okay, the y-axis and the x-axis, we'll assume it's 0. So you are moving from 0 towards the right. Are you increasing the kinetic energy or are you decreasing the kinetic energy? If you move from left to right.
Increasing, sir.
Good. That's what I wanted you guys to understand. That as ma'am was explaining, she gave you that, but what you needed to do is to check the base, that you are moving from 0 to a higher number here. You are moving from, because here we're talking about the kinetic energy. If we had said the number of particles, then you would have looked at the graph. That's all I wanted you guys to grasp. Because I did not want you to memorize. I wanted you to grasp that and understand why. So thank you very much. Thank you. Ma'am, I'm done with the legal that I wanted to highlight to them as well.
Okay.
Yes.
Before we move on, we do have 10 minutes. Maybe I should go back to the organic chemistry.
Yes.
Yeah, so that we can just highlight it and see if we can just best help our learners. Let's not assume that we know. I saw the solutions were there on the chart. Aye, our kids are communicating, my friend. They are. Ish, yeah, need to get there, it's a long way. Ne?
Stop there. Stop there. Go back. Go back.
Where?
Go back. I'll show you. I think you had something which, yeah, here as well. What could also help them is that now, after what you've said, that reaction, and then you said heat is on the right, it's a product. Heat there, it's on the left, it's a reactant. They could as well use the colors to guide them. Yes, thank you.
Yeah,
No, it's fine. I
definitely.
think we understand. Yeah, we can move to whatever you want to discuss.
All right.
It's fine. Thank you.
I'm sure when you're seeing this again, it's just like, yeah, now I know what's happening here. I'm able to understand. They said it's almost time for essentials. We've got about 8 minutes. Let's quickly run into that one. So I'm expecting everyone to answer. Let us all answer these questions. Ne? This one here. Write down the type of the reaction that occurs at A. I already gave my answer. I said addition. What is happening at C?
Elimination at C.
Elimination. Thank you. And then, why would you say that?
Why would I say that? Is it elimination?
What happened? Why did you say it's elimination?
Is it because compound X is like at C? It's I don't know how to explain this, but like
okay, let me help you. You no longer have HBr here. It was removed.
Yes, ma'am.
Yeah. But I think when you write it down, you will clearly see what you are talking about. Right?
Yes.
Write down the name or the formula of the catalyst for D. Remember, organic reactions are very slow reactions, so they need to be supported so that they can speed up. So most of the time we need catalysts, and I gave you a list of catalysts for possible things that you can put there. First and foremost, we need two reagents here. I know they want one, but in your case, you must know two, so that when you ask the other in the exam, you know what to answer.
Is it platinum, ma'am?
Platinum. I told you, don't say is it, it's platinum. Full stop.
Yes, ma'am.
And what is the reagent? What was added here? It was H2. It was hydrogen gas because I've got hydrogens here.
Yes, ma'am.
Don't say it must, it is, it's platinum. Now, reaction B is substitution reaction that takes place in the presence of water. Okay, before anything else, pens down. We've got substitution and elimination, okay? For substitution, you can either add water or a weak base to substitute. It's just a matter of removing the HBr and adding the OH. But when it comes to elimination, we're going to need a stronger base. We are trying to forcefully remove something like the OH or the HBr or the Br. So that will take more energy. Bear that in mind so that you know the difference between substitution and elimination. Okay. Substitution is just swapping something on the line. I'm putting this one instead of that. It's not going to take too much energy. But for me to remove something permanently, I'm going to need something stronger. Hence, for elimination, we're going to use a strong base. And then for substitution, it's a weak base. So that will be the difference between the two. Now let us continue to answer the questions. 4.3.1. We've got 3 minutes to answer this question. Type this, write down the type of a substitution reaction that is taking place there. What did we substitute the Br with to get the alcohol?
Hydrolysis.
Hydrolysis. Because they added water to the salt. It's hydrolysis. Full stop. Annie?
Yes,
Thank you very much. That's a perfect answer. Now it says, write down 2 other reaction conditions for this reaction. I think you've got water.
Yes.
For your substitution. I gave you the other one. What was that?
Mild heat.
Mild heat, and the other one?
Halocanes dissolve in ethanol.
Weak base. Just a weak base. Remember, this is substitution. If it were elimination, it would have said concentrated base or a strong base, not concentrated, or a strong base.
Yes, ma'am.
Yeah. Anybody else? What is the IUPAC name of Y? You know why I chose this question? The only thing that is not on this question is the physical properties of organic chemistry. But here you've got the nomenclature, the naming and writing of compounds, the reactions, all of them are combined. Hence, I chose this question specifically. So you're supposed to write compound X before you start answering these questions, compound Y, compound Z, and then you name all of these compounds. By the time you answer here, all your answers you just collect from your scheme are there. Are we writing the formula? Okay, let me just interrupt you for a little bit. I'm sorry for the interruption. I know you are writing the formula. Please do write it in the meantime. We need to pause now so that we can have a video on the essential skills, and then we will resume back once the video is being watched. All right, I'm going to stop sharing now, and then we will come back to this.
I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Center, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Center, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident: mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief. Experiments are performed, simulations studied, and exam questions are explored, not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner, learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment, and it's covered using fantastic Pasco software and hardware so that you can actually participate in the experiment. Also, lots of useful simulations, particularly from PHET, the photoelectric effect. You'll talk about projectile motion today, and also momentum. And then talk about applications like what would the International Space Station be without its solar panels to generate electricity? When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it'll show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014 because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck, because that only helps with the multiple choice. But I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
Okay, learners, we are back. This is the time now where you ask questions, not only from the slide. You can ask questions that are pressing from your side, like something that you don't clearly understand, so that we can address it on this platform. You can type in or communicate with us. Any means of communication is welcome. Okay. Yes, colleagues. Learners? Professor?
Yeah, I can hear you.
Yeah, but I think I'm blank now. I'm not hearing anything.
From the learners.
From everyone, I'm only hearing you now.
They seem to be still in. They are just muted.
Okay,
But your slides are very faint.
yeah, it's saying that on my side also. It says it's not responding, but I've stopped sharing and I've opened the platform for anybody to ask questions.
Okay, Kandi has responded. She says they are still all here.
Mm-hmm. Okay.
Right, there's a question in the chat there that's saying, I'm still confused with the first graph about amount of particles and kinetic energy. Why is D the answer when A is the highest amount of particles?
We are not looking at the number of particles. We are looking at the energy. Hence, we said they must now compare the base. That's why I said they should think of it from starting from 0 to the highest as they move towards the right. So with A, it's still, they have the highest number, but the kinetic energy is not that much.
And to add on, in A, you've got higher number of particles, yes, but we are looking at the tip. Remember the activation energy. It is that minimum energy required to start the reaction. And again, if a catalyst is added onto that system, the minimum energy will be minimized, but the activation energy will be minimized. Hence, the steep of the graphs are different. A is high up there and D is low. The actual fact is that we've got equal amounts of, it's just that the peak for graph D, it was reached quicker at a lower, at a lower time as compared to the one for A. It's not like A has got more particles than D. They do have, look at the broadness of D and the broadness of A. They're almost the same. It's just that this one came quicker than that one at A. We are looking at the rate of reactions here. I tried to, to share a complete past paper so that you can just look at other questions, because remember, for the purpose of this, we selected only a few that we looked for, but it just refused to load. But anyway, nonetheless, we still have all these platforms that you can ask questions. Like I said, we don't need to ask questions coming directly from the slides. You can ask anything that you're not comfortable with, that you want to understand, so that we can help you understand it. Professor?
I can hear you.
Yes. Do we have any question that we want to ask the learners?
Because, hello? Yeah,
Yes.
maybe because of the stage maybe go down slide by slide. If we see something, we may alert them to TR. We've started with that one. We've explained that one. Go to the next one. Yes, this one. Let me ask them the question. Write down the name. That's fine. Write down the name of the. That's fine. Define the term for experiment. Calculate the rate. Yes, number 5.5. In which experiment did the learner use a higher concentration of hydrochloric acid? Let the learners, one of them, explain to us how did they reach that conclusion. Because you've been a mother. Now I want them to wriggle free and try and explain to us.
Learners, we are on question 5.5. We are trying to differentiate between experiment 1 and 2. And why do we say experiment 1 was faster than experiment 2?
Ma'am, can I answer?
Yes, please.
An increase in concentration will increase the number of particles per unit volume. This leads to more collision and hence more effective collision per unit. The rate of reaction will increase.
Make it. I must send you an e-wallet. I'm not bribing you, but I want to send you an e-wallet. Can you repeat yourself?
An increase in concentration will increase the number of particles per unit volume. This leads to more collision and hence more effective collision per unit time. The rate of reaction will increase.
You made my day. Hence, I'm saying you deserve an e-wallet from me. I'll send you a packet of chocolates just for getting this one correct.
Yes, ma'am.
You are 100% correct on this note.
Let's move over.
Mm-hmm.
The thing I want to ask them, I think this is straightforward. But what I want them to note is how to calculate the number of moles, because it's not given there. They are just given things that they can use to get the number of moles. So they must also revise that.
Yes.
They must revise that. Okay? Yes, we can go to the next one. Let's see.
Remember, here is to study your graph. I put it back here so that it relates to the information that you're looking at. This is the pressing matter again. I don't want to say to learners that they must ignore these questions. They are easily answerable if you understand them. But I am not encouraging learners to spend 5 minutes to try and answer a controlled variable for 1 mark answer. If you're not sure of this one, you skip, you go and continue with the rest of the paper. Then once you're done, you can come back and answer these questions. But do not spend more time on one question when you can answer other known and answerable questions. Professor, can I move on?
Before you move on, somewhere where I was helping, a learner gave a very short and brief answer about independent and dependent. And she said, or she said, so that I mustn't be seen to be, yeah. She said that the one that which you manipulate, the one that which you change is the dependent variable. The one that you change as you're doing your experiment. And I found that it somehow releases the confusion between the dependent and independent. Okay, we can continue. Because some of the answers we get them from you as you understand it. Okay, I think this one you said something about it. Unless if you're seeing something that learners, as we are scrolling down, if you see something you do not understand, please feel free to ask. That is the whole purpose of today's workshop. Hence, we're starting again, going slow by slow, so that if in case you missed it and you couldn't have the opportunity to ask, this is your opportunity to ask or even comment. Okay. All right.
Professor?
It looks like your slides are moving on the left-hand side. With my computer, they seem to be stuck.
Your computer is frozen. Professor?
Yes.
I think we have come to the end of our program.
Right. Oh,
Yes,
yeah, my computer is stuck.
yes,
Yes.
we need to allow Mr. Bugosi to take charge now. But before we do, I'd like to take this opportunity to thank the learners on behalf of myself and Professor Vusi Mulawuzi for being good audience, and allowing us to part our information with you. And remember, this is a carry-on session. It doesn't end today, but Mr. Bugosi will give you everything that you need, or that I was going to say from now on. But otherwise, thank you very much on my side. Professor?
Go. I want to ask the learners something. Please don't go. All learners, I wish you could unmute your mic and clap hands for the wonderful workshop we've had. Please, all of you, unmute if possible, or clap hands, or then send. Yeah, I think you can unmute. I'm not sure. Yeah, because some people could even participate. Just unmute all of you and clap hands for the wonderful workshop that we've got. Thank you, thank you, thank you.
Bugosi?
Right. Thank you so much, Dr. Suela. Thank you so much, Prof. Mulawudzi. And thank you so much to you, our VIPs, our MVP, for joining us this morning and for forming part of the entire June matric exam workshop. It was a major success because of your participation and your contribution. So from the bottom of my heart and on behalf of SAIP, thank you so much. Right, so if you'd like to watch today's session, the chemistry session, it is available on YouTube. And if you also like to catch up on the physics workshop, you can also go to our YouTube channel and watch that particular session. Our channel is the South African Institute of Physics on YouTube. Please, 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 please subscribe to stay in the loop with all our future content. And also, at the beginning of the workshop, we played the Metric Essential Skills workshop video, which was compiled by Dr. Fish. It has very, very powerful resources that can really help you in acing your examination. So please go back to the start of this video to watch how you can get your hands on the workbook and how to access the materials that will help you in your exam preparation. Now, as a continuous support throughout the year,
we'll also be sharing a link to a WhatsApp group where you can reach out to our facilitators with any questions related to physics or chemistry. So this will support you throughout the exam season or throughout the academic year. We will email you that link or SMS it to you a little bit later on. Please feel free to reach out to us at any time to ask any questions related to physics, but please make sure that you stay on brand. Ne? And then this is not the end of the road. We will be back in September for the prelims preparation workshop, both in person and obviously online or virtually. And then again, for the last stretch in November, we will be back again with the last round of workshops in person as well as online to help you really prepare for your final examination. Please follow us on social media. On Facebook, we are South African Institute of Physics. Instagram, we are at SA Institute of Physics, one word. I will repeat the social media handles. Facebook, South African Institute of Physics. Instagram, it is at SA Institute of Physics. Please follow us so that you can stay in the loop with the many things that we have there, such as the physics profile, videos that we have out there, and the many things that we will be offering you in supporting you throughout the entire academic year. Thank you for joining us. My name is Bukosi Mashela. All the best for your chemistry paper, your physics paper. And I always say that if you fail to plan, you plan to fail. But because you came here today and you form part of this workshop, you are definitely setting yourself up for success. So all the best. Go in there knowing that you got this, and the facilitators are available to assist you if you do have any questions through the WhatsApp group, which will link that will send to you a little bit later on. Enjoy the rest of your Saturday morning, and yeah, catch up soon. Bye.